Good afternoon, everyone. Welcome back. Thank you for joining us. I'm glad you're here. I'm Steve,
We are definitely glad you're here, and I'm Scott.
and together we're Backyard Musing Science and Technology Channel.
Yep, and we're talking about an interesting one today. I mean, this is kind of a weird topic. It has to do with climate change a little bit, but this is kind of a cool story. So, see what happens.
A new electrolyzer turns waste-derived syngas, like synthesized gas, into ethylene, which significantly lowers energy input. Ethylene sits at the center of modern manufacturing. It's used to make plastics and many other everyday materials, but producing it often comes with a major climate penalty. For every ton of ethylene created, 1 ton of carbon dioxide is produced. With more than 300 million tons of ethylene produced each year, that adds up to an enormous source of emissions that researchers want to shrink and ultimately remove. Would you like to know more?
Yeah, in a new study from Northwestern University, Ted Sargent's team reports an electrolyzer designed to push ethylene production toward a cleaner model by linking waste and renewable electricity. The device uses electricity to turn syngas into ethylene. Syngas is a mixture of carbon monoxide and hydrogen that can be made by gasifying plastic waste. That starting point matters because it can be easier to upgrade syngas into valuable chemicals than it is to build the same products directly from carbon dioxide. The researchers also introduced a new material that helps the reaction run effectively, and they built the system to cut the overall energy required.
Yeah, this all sounds good, but it's like over my head. I'm trying to follow this, and I'm not, they're building it into one thing that can be built into others, but it takes less toll on the environment. I don't know.
Yeah, well, the carbon, when they mentioned carbon footprint, that's when my attention span kind of went away, because we talk about those guys that jet set all over the place in huge commercial planes and private commercial planes, and they offset it by buying carbon offsets. What is that? I don't know. Anyway,
it's a scam, is what it is.
On that one, it is a scam. Yeah.
The results published in Nature Energy on February 17, 2026 point to a potential route for making ethylene with renewable power, reducing the need for fossil-based inputs along the supply chain. Sargent is the Lynn Hopton Davis and Greg Davis Professor of Chemistry at Northwestern's Weinberg College of Arts and Sciences. Why is chemistry in the science? Arts and science. I was thinking liberal arts. And a professor of electrical and computer engineering at Northwestern's McCormick School of Engineering.
That's an interesting mix there. Today, with most ethylene is made through steam, a process that uses high temperature steam to break down crude oil into smaller chemical components. Bless you. While effective, this method relies heavily on fossil fuels and consumes large amounts of energy.
Scientists have been investigating ways to replace it with electricity-driven processes powered by sources. One possibility is to convert carbon dioxide directly into ethylene. However, that reaction requires significant energy input, making it difficult to compete with existing industrial methods.
Instead, Sargent's team focused on syngas, which is produced by heating plastic waste in a low oxygen environment. Syngas contains carbon monoxide and hydrogen, like we said earlier. Because it is chemically closer to ethylene than carbon dioxide is, transforming it into ethylene requires less electricity.
To make this conversion practical, the researchers needed to design a different kind of electrolyzer, a cell that uses electrical energy to drive chemical reactions. Most electrolyzers rely on liquid water mixed with dissolved salts that supply both positive and negative ions, kind of like a battery.
Yeah. The team explored whether they could build a system that operates with gases on both sides of the reaction. In their design, carbon monoxide from syngas would enter into one side, the cathode, while hydrogen would be supplied on the other side, the anode.
Salt provides the positive ions, the cations, that devices copper catalyst needs to stabilize key intermediates in the reaction. Bosi Peng, not making that name up, a postdoctoral researcher in the lab and first author on the paper, search for the right material that could trap those ions while also keeping them loose enough to react within the system. And by the way, even if it was a made-up name, I wouldn't tell you.
Yeah. The material, sodium polyacrylate or acrylate, I guess. Okay. Creates a microenvironment within the system that mimics a liquid salt bath while keeping the system dry of liquid water. The result is a process that is more than 60% more efficient than the most energy efficient prior electrified processes that turn carbon dioxide into ethylene.
Next, the team plans to try to reduce the energy consumption of the device even further, so it's on par with energy used in steam cracking. They're also using artificial intelligence and machine learning tools to find catalysts that would make the device even more efficient. Ultimately, the goal is to create a device that can scale up to be used in industry to continue to reduce ethylene's carbon footprint.
Okay.
I like it. That's entrepreneurism right there.
Yeah, and when we're talking in the middle of the story, I could just see these people in a laboratory, and they got their like white coats on and their pocket protectors and all that stuff, and they're messing around with these.
I got pens in my pocket that must get protected.
Yeah, just messing around with all these different liquids and electricity, and just having a fun time being scientists. So pretty cool.
Yep. Love them just like we love mice.
We do. We love the scientists. You know.
Yep.
Okay.
All right, folks. Thanks for joining us, and this time, enjoy your Sabbath.
Okay.
I said that prematurely yesterday.
Say it. We'll see you on Monday. Take care.
Yeah.
Thanks. All right,
brother.
So tomorrow, cleaning the church, even though we don't have church.